Welcome back to 15th Street Automotive. Today we're working on a 2007 Mazda CX-7. The customer concern is a check engine light and she's smelling fuel. So we take fuel system problems pretty seriously here. So let's take a look at this one and figure out what's wrong with it. Alright, with the engine running, you can see the check engine light is on. Let's get into the scan data and see what we see. Alright, we got the vehicle information all in there. Check for codes. Alright, we got a P0441 incorrect purge flow and a P0455 large Evap leak, so that might explain her fuel smell. So let's take a look at that. So the purge flow, that's a pretty common problem to have on the purge valves will actually start to leak. So the purge flow issue, depending on how bad that leak is, that purge flow code could be just an indication that the leak is so bad. It never sees the pressure change when it's purging if the leak is bad enough. So it'll look like the purge valve's not working. So anyway, we can test that purge valve fairly easily. Let's check the purge valve and then we'll smoke this thing and see if we can't find a leak in the system, hoses or tank or canister or whatever. Alright, so we got the thing running. This is our purge valve right here. Vacuum comes in off the engine into this side. On this side it goes out to the fuel tank, and that's how it pulls those fumes in. So we're going to pull this line off of here. These things are super common for leaking. So I'm not feeling anything here. Let me put this on here. I'll show you what so there is nothing leaking on there at all through there. So as you can see, it's at 0. It is what's common on these things is the valve inside will stick and it'll leak without being activated. So we're going to activate this thing, make sure it's working the way it's supposed to. We'll go to active test. We're going to go to purge cycle. We do not need any information. Alright, so at 0 we're going to increase this, and as you can see it pulled a vacuum on that gauge. So that's it pulsing right there. So if we increase that, it's going to pulse faster. Okay, decrease it, it's going to pulse slower. Okay, so that purge valve is working good. That's not our problem. So we'll go after the Evap large leak and we'll put some smoke in the system and then see if we can see where it's leaking. So this is our smoke machine. Hook it up to the battery so it gets its power. So what we can do with this thing is this white hose goes through the meter. This is a flow meter right here. So if I turn this thing on, you can see this little dial right here and listen to it. There's that little ball in there that it's flowing now. If I stop the flow, it falls. So it's up and it falls. So it's a flow meter. What I'll do is I'll stick this hose onto the hose that goes back to the tank, and it's flowing full blast right now because it's flowing into the system. Has to fill the lines, fill the tank, fill the canister, fill everything. But if there's any leak from here all the way through the whole system to the cap, if there's any leak, this will continue to flow. This ball will continue to stay high. If it drops, then we don't have a leak. Then the leak is that set the code is intermittent. So normally they give you a option in the scanner to open or close the vent solenoid, the vent canister solenoid. And on this one, on the Mazda, it doesn't give you that option. It gives you an option for the Purge, but not for the vent control solenoid. So what we're going to do is we're just going to pinch off the line that goes to the vent control solenoid so that we can test the system for leaks. If we get through the whole system and there are no leaks, then we will spend some more time checking out that canister vent solenoid. But there's no option in the Autel scanner to close that. So there's a way around it. We're just gonna do a couple extra tests to work our way around it. But so I'm gonna show you how I pinch that off, and then we'll put some pressure to it and see if we got a flow. If we never reduce flow, that means we have a leak in it. Then we'll put smoke to it and see if we can't locate where that leak is. All right, so we're just going to use normal vice grips, and that is our canister. And we're just going to basically just pinch off this hose right here. So it's completely closed off. So this hose here goes up over the tank, and let me see if I can't take you through here. So it goes up over the tank. So it comes over the tank from that on that silver hose down to there, and if you look up there, let me see if I can get a light on it. Right up there is the vent solenoid. That's the canister vent solenoid. If we were to smoke it, you'd see smoke coming out of that right now because it's naturally open. If we need to, we can get to that connector and provide power and ground to make sure it's opening and closing, but we got some other things we can do before we get there. So with that hose pinched off, we're basically doing the job of the vent solenoid. So let's see if the rest of the system has any leaks, and then we'll move on from there. All right, so we're flowing there. We've got it flown into the system, and so it's going to fill up the tank. As it fills up the tank, it's going to fill up the canister, and it tests the cap as well, because there's a line coming from the tank up to the cap that will it'll pressure test that. So we're still got full flow here. So our problem, although our problem is likely not the vent solenoid, because we have it isolated and we still have our leak, and it is a major leak. So next thing to do is to pull this line off. We'll coil this back up, get it out of our way. We're going to turn our dial to smoke, and then we'll pull the smoke hose off. And as you can see, we're making smoke. So now we'll put smoke in here. So the meter isn't functioning when you have it on smoke. So we're putting smoke in it. We're going to put the car back up, and we will see if we can see where the smoke is coming out at. All right, so I'd like to show you all the fancy ways I look for this, but our problem is pretty darn obvious. If you look at this, that's the back side of the canister. That is that's a good leak. There ain't no doubt about it. So I didn't even notice that it was when I was down here pinching off the hose. So that's where I pinched off the hose at right there. I didn't even notice it. But if you look here, let me get out of the way of the smoke here. It looks like mice have eaten it. Because nothing else is damaged underneath. It just looks like it's been eaten up. But that's our leak. I don't see any other leaks, but with that leak so bad, it's not gonna, it loses all its pressure there. It's not gonna show us any other leaks. So this thing is gonna need a charcoal canister. Not a big deal, not a big job to do. So we'll write it up and get it sold. All right, so I wanted to show you the code criteria for those different codes. Here's the DTC P0441. This is the set criteria here. PCM measures the purge line pressure under the following conditions. If the vacuum between the charcoal canister and the intake manifold does not reach a specification, PCM determines that the evap system is clogged. Since there was the charcoal canister was wide open with that big hole in it, it was never able to create a vacuum, and it reads that through a pressure sensor in the fuel tank. Since there was a big opening in the canister, it never pulled a vacuum. It set the P0441 code. So that's why we had that code. Now let's go look at the P0455 code. All right, for some reason, all data didn't show a P0455 code in there. I had to go back to the scanner to make sure I was looking at it right. But I got it on Mitchell. This is another reason why you need two different information systems, because there's holes in all of them. So I can pretty much do everything I need to do between the two of these through Mitchell and all data. So anyway, so P0455 is our code. The detection condition, so basically the set condition, is the PCM measures the pump load current evap line pressure when a specified period is passed after the evap system is sealed when monitoring conditions are met. If the load does not reach the reference current value within the specified period, the PCM determines the evap system has a gross leak. So basically what it is it watches the vacuum on the evap system to decay at a certain speed. And if it decays too fast, then it's going to end up being it's going to set a code for a large leak. Because we have this huge hole in the canister, our problem, it sets that code pretty easily, pretty obviously. So anyway, I wanted to show you the set criteria for those two codes. We're going to sell them a canister, and unless something goes terribly wrong in the process of fixing it, you can count on the fact that this is going to fix our problem. If it doesn't, we'll crank the camera back up and we'll document all of that. But thanks for watching.